All right, let's jump into another deep dive. Today we're looking at how to make sure your web development projects are as secure as they can be.
And we've got a whole bunch of different resources we're going to be looking at today, right?
Absolutely. We've got technical specs, things like those for JSON web tokens.
Oh, yeah,
Yeah,
JWTs.
JWTs, exactly. And we've got some blog posts with some real actual code examples that you can work with.
Always good to have some hands-on stuff.
And even some of those security cheat sheets that the pros use. So
From OWASP, those are always good.
yeah, think of this deep dive as like a shortcut to making your applications, way more secure and resilient.
Yeah, I think what all these sources really highlight is that web security is like a puzzle
Yeah,
with a lot of different pieces.
right.
You got to think about all the little details,
Yeah.
like how you manage those JWTs all the way up to the big picture.
Mm.
How do we prevent these common attacks from happening in the first place?
So let's start with those JWTs then. Those JSON web tokens, we've all heard of them, but one thing that really surprised me is that the length of your secret key
Oh, yeah.
actually needs to match the size of the hash function you're using.
Mm.
That sounds simple, but it's something that I think a lot of people miss.
It is. It is. And choosing that right key length, it's almost like walking a tightrope, right? You
Yeah.
want to have strong security, so it's got to be long enough. But you also want your application to be fast.
Right.
Nobody wants to wait forever for a page to load.
Right. So how do you find that balance then? How do you figure out?
So it really depends on, which algorithm you're using for those JWTs. Like
Mm,
if you're using HMAC, the secrets are going to be processed super quickly.
yeah.
But if the key is too short, then it can be vulnerable to brute force attacks.
It's like how we always say longer is stronger for passwords.
Mhm.
It's kind of the same idea
Yeah.
here with those keys, right? The longer the key, the harder it is to crack.
It is. It is. And it's not just about encryption, though.
Right.
The data, it needs to be, it's got to have integrity, too.
Okay.
Luckily, though, a lot of those standard algorithms, the ones that are approved by the JSON Web Algorithms Group, they cover both. So you got encryption, you got integrity all in
Oh,
one.
so you don't have to worry about it as much if you're using those standard
But,
ones.
but if you're using something outside of those standards, it gets a little trickier, right?
Yeah. What happens then? What do you have to do?
Well, you might need to think about nesting JWTs.
Nesting. Yeah.
Yeah, so you basically have a JWT inside another JWT. The
Mhm.
inside JWT, that's the one that's signed. It makes sure that nobody's been messing with the data.
Yep.
It's especially important if the way you're encrypting, it doesn't already check for that.
Okay, I see. So that makes sense. It's like an extra layer of protection.
Exactly, exactly. Yeah.
Okay. All right. So we've talked a lot about JWTs. Let's switch gears a bit
Yeah.
and talk about React Router. Specifically version 6.
Oh, yeah, version 6.
We've got this great blog post from LogRocket that really walks you through some of the best practices when you're working with React Router and authentication.
Oh, yeah, I really like this post. It's very hands-on. They have actual code examples
Yeah.
you can just take and use.
Yeah, and it shows you how to set up things like protected routes.
Mm-hmm.
Use auth hook, and they even have this neat little trick with the auth provider
Oh, yeah, the
and
all
make sure that authentication is consistent, throughout your whole application.
Mm-hmm. Keeps things nice and simple.
Right, yeah. And they even include a link to Code Sandbox.
Oh, that's cool.
So you can actually play around with the code and see it working in a live environment.
I love those.
Yeah, and imagine, building this out, step by step yourself, like seeing how each piece fits together.
Yeah, that's what makes this blog post so valuable.
Exactly, yeah.
You can actually understand it.
Now, they've even got an example in there for two-factor authentication.
Oh,
That extra security layer where you need a code from your phone or your email or something to log in.
right, right. And it's not super complicated to set up either.
Right.
They keep it pretty straightforward.
And they didn't forget about those of us who are using Author.
Right.
They actually link directly to the official author's documentation. So it makes that integration process so much smoother.
Oh, that's nice.
Yeah. This whole discussion about authentication, it really makes me think about, how often do you actually go back and look at your own authentication flows
Yeah.
and think about any vulnerabilities there?
It's one of those things that, it's easy to forget about, but it's so important.
Right. It really
You
is.
got to make sure you're reviewing those regularly.
Right. Ready for something a little bit, I don't know, suspenseful?
Ooh, okay.
Let's talk about a security threat that's kind of sneaky, often overlooked, but it can cause some serious damage.
All right, I'm listening.
And that is CSRF or cross-site request forgery.
Oh, yeah, CSRF. That's a good one. Think about it like this. You're logged into your bank account, right?
Mm-hmm.
And then an attacker sends you this link, looks totally harmless.
Yeah.
You click on it,
Mm-hmm.
and boom, it sends a request to your bank,
Oh, no.
maybe transferring money out of your account
Yeah.
without you even knowing it.
That's terrifying.
Yeah.
It's like someone forging your signature on a check or something.
It is. It is. It's really dangerous. But luckily, we've got that OWASP cheat sheet to guide us through this.
Yeah.
Gives us some ideas on how to prevent it.
So what are some of the techniques they recommend?
Well, one of the I guess best ones is called the synchronizer token pattern. So basically, the server, it generates a unique token for every user session, or even better, for each request.
Oh, wow.
And that token gets embedded in the client's forms.
Right.
Then when the user submits a form, the server checks, is that token there?
Yeah.
And does it match?
Right.
If it doesn't, the request is rejected.
So it's like an extra verification step.
Yeah, exactly. Like a secret handshake.
Right, to make sure only the legitimate requests get through.
Exactly.
So that's one technique. What are some of the other ones they recommend?
There's also the double submit cookie pattern. But it's important to differentiate, I guess, between the basic one
Right.
and the signed version.
Okay.
Basic approach, it's simpler, but a really clever attacker, they could figure out a way around it.
Oh.
So it's better to use a secret key, like in the signed version. Then the attacker can't just inject a fake CSRF token.
So it's like adding an extra layer of encryption to that secret handshake.
Exactly.
I like that. Okay, so those are for forms, but what if you're working with like AJX or APIs?
Yeah.
What do you recommend then?
Custom request headers, those are going to be your best friend there.
Okay.
It leverages that chorus pre-flight mechanism. So basically, it forces the browser to do a check
Right.
with the server before sending the actual request.
Right. Okay, so it's like another layer of, hey, are you sure you want to do this?
Exactly.
Okay, all these techniques, they're great, but I think, one thing that OWASP really emphasizes that I want to point out here is that no single solution
Right.
is foolproof. You've got to think about security in terms of layers.
Yeah, they call it defense in depth.
Right.
It's like building a castle.
Okay.
You need the walls, you need the moat, you need guards, you need maybe a dragon or two.
Okay, I love that analogy. So we've got our layers.
Yeah.
But what about some specific tools? What about the same site cookie attribute?
Oh yeah, same site. That is a powerful tool, especially when it's used with other, CSRF prevention techniques. So basically, it tells the browser when a cookie should be sent along with a request. And that can make it much harder for attackers to hijack someone's session.
But you're saying that even with same site, you can't completely ditch those CSRF tokens.
Right. It's not a perfect solution. There are still some ways that attackers could get around it.
So what do we do?
Well, there's a great example on GitHub that actually shows how same site alone might not be enough to stop a determined attacker. So you really need to be, verifying the origin of requests using those standard headers.
Right.
Origin, referer.
So it's like checking the return address on a suspicious package, to make sure it's actually coming from where it says it is.
Exactly. But you got to keep in mind, if you're using proxies, things can get a bit trickier. You might need to look at headers like xforwarded host to really see the true origin.
Oh, okay, so that's something to watch out for then.
Yeah.
And this kind of brings us to this scary thought, which is client-side CSRF.
Oh, yeah.
Where attackers, they can actually hijack your own JavaScript code.
Yeah, they use your code against you, essentially. Yeah. And this really highlights how important it is to think about security on the client side.
Right.
Not just on the
Not just the server, yeah. So it's like someone breaking into your house and then using your own tools to cause damage.
Exactly.
So how do we protect against that then? What are some of the things we can do?
Well, OSPEM, they have some great advice on this.
Yeah.
They really emphasize validating all user input.
Right.
And being very careful about how you build those requests on the client side.
Okay, so it's all about like minimizing those ways that attackers can, like, manipulate that client-side code.
Right, you got to be thinking like an attacker.
Yeah.
How could I exploit this?
Right.
And then you fix those holes.
Okay. So speaking of client-side code, let's bring it back to React.
Okay.
And there's this one feature in particular that just like screams danger to me.
Oh, which one?
And that's dangerously set inner HTML.
Oh, yeah. I mean, the name kind of says it all, right?
Right.
It's a very powerful tool. You can do a lot with it.
Yeah.
But it is also super risky if you're not using it the right way.
Yeah, it's like giving someone a loaded gun and just saying, "Hey, just be careful with that." Okay.
Exactly. And the thing is, it's so tempting to use it. You know, sometimes when you're working with React,
Right.
the normal ways of rendering things, they just feel too limiting.
Right.
So you're like, oh, I'll just use dangerously set inner HTML. It'll be a quick fix. Yeah. But trust me, finding a safer way to do it is almost always better in the long run.
So when is it actually okay to use this? When is it actually necessary?
There are very few situations where it's really necessary.
Okay.
Like, one might be if you're getting HTML from a source you absolutely trust,
Right.
like a markdown parser or a rich text editor.
Hmm.
But even then, you got to be super careful. Make sure that HTML is completely sanitized.
Right. So no sneaky code hiding in there.
Exactly.
Okay. So what are some safer alternatives then?
Template literals or JSX expressions. Those are good for like putting values into your HTML.
Mm-hmm.
And if you need more control over how things are rendered, you can use React's create element function. It can like build those elements dynamically for you, and it's much safer.
All right. So it sounds like it's all about, choosing the safest option whenever possible, even if it means writing a little bit more code.
Exactly.
Right.
Security's worth it. Yeah.
It is. All right. Let's move on to another kind of tricky security threat, which is cross-site request forgery. We touched on it a little bit earlier, but it's worth revisiting. So CSRF, it's basically about tricking a user into performing an action on a website without them knowing it, without them consenting to it.
It's all about exploiting trust, the trust that a website has in a logged-in user.
Yeah.
So, for example, imagine an attacker sends you a link.
Yeah.
And when you click it, it triggers a request to your online banking site and transfers money from your account to theirs.
Oh, wow. So it's like having someone forge your signature on a check, but in the digital world.
Exactly.
Yeah.
And because you're already logged in, the website thinks, oh, this is a legitimate request.
Right.
So it processes it.
Oh, how do attackers actually do this? What are some of the methods they use?
Well, one way is by hiding those malicious requests inside, like seemingly harmless actions, like clicking a link or loading an image. Imagine, you click a link, looks totally innocent, but secretly it sends this hidden request to your bank, maybe changing your account settings without you ever knowing.
Oh, wow. So it's like a digital Trojan horse, right? Looks harmless on the outside, but it's got that malicious payload hidden inside.
Yeah, perfect analogy. And they can also use forms, JavaScript, even social engineering tactics to trick people.
Okay, so it sounds like it's not just about technical safeguards. It's also about, educating users to be wary of suspicious links and emails and things like that.
Definitely. Being aware is half the battle.
All right. But let's get back to the technical side for a minute. How do we protect our React applications from these CSRF attacks?
One common and really effective approach is to use CSRF tokens.
Okay, we talked about tokens earlier, so remind me how they work in this context.
Yeah, so a CSRF token is this unique, unpredictable value that the server generates and includes in every form or AJX request. Then, when the user submits that form, the server checks, hey, is that token there? And does it match?
Right.
If it's missing or it doesn't match, the request is rejected.
Okay, so it's like a secret password that only the server and the legitimate user know.
Exactly. So the attacker, they can't forge a valid request because they don't have that token.
Right. Okay, that makes sense. And what about that same site cookie attribute we talked about before? How does that fit into all of this?
Same site's a great tool for stopping a lot of those CSRF attacks. especially the ones that rely on how browsers automatically send cookies with requests.
Right, right. Like those hidden requests we talked about earlier.
Exactly, exactly. So by setting that same site attribute to strict or lax,
Mm-hmm.
you're basically making it much harder for attackers to hijack a user's session.
Okay, but you did say that it's not like a silver bullet.
Right.
It's not perfect.
Yeah, it doesn't work perfectly in older browsers,
Right.
and it doesn't work for all types of cross-origin requests.
Okay.
So it's best to use it together with other CSRF prevention techniques, like those CSRF tokens we talked about.
So and goes back to that defense in depth strategy.
Right.
Multiple layers of protection is always going to be better
Always better.
than just relying on one thing.
Yeah.
Okay. Now speaking of layers, there's this particularly sneaky type of CSRF that I think we should talk about, and that is client-side CSRF.
Oh yeah, client-side CSRF. That's a tricky one. So basically, attackers are exploiting vulnerabilities in
Yes.
your client-side JavaScript code
Yeah.
to trick it into sending those malicious requests.
So instead of them like forging those requests directly,
Yeah.
they're actually manipulating your code to do it for them.
Yeah, it's pretty sneaky.
Pretty devious.
And what makes it even harder to stop is that those traditional like server-side CSRF prevention techniques, they might not be enough.
So even though the code has been manipulated, those requests are still coming from the user's own browser.
Exactly. It's like the browser saying, "Hey, I sent this. It's all
Yeah.
good."
Right. Right. And it includes all those cookies and headers that it normally would.
Yeah. So it looks legitimate.
So how do we protect against this then? What can we do?
The key is to make sure that your client-side code is as secure as possible.
Okay. But what does that actually look like? What are some of the things we can do?
Things like using secure coding practices,
Mhm.
validating all user input, like really carefully,
Right.
and avoiding things like dangerously set inner HTML.
Right. So it's all about being like extra vigilant on that client side.
You gotta treat the client side with the same level of security
Yeah.
as you treat the server side.
Okay. And it sounds like you really have to be aware of this client side CSRF, especially if you're using like third-party libraries or connecting to external APIs.
Oh yeah, anytime you're bringing in code from somewhere else,
Right.
you gotta be extra cautious.
So it's like building a security perimeter around your entire application.
Yeah, good analogy. It's about creating a security-conscious culture.
Yeah. All right. So this part of our deep dive, it's been a real eye-opener for me.
Yeah, me too.
We really explored the complexities of XSS, CSRF, and how important it is to secure both our client side and our server side code. And we've only just scratched the surface. I mean, this is just the beginning. There's so much more to explore.
We've only just begun.
We've only just begun. And that's what we're going to do in part 2. We're going to continue our deep dive. We're going to go even further into this fascinating world of web security. So stay tuned.
Can't wait.
Yeah. All right, welcome back to our security deep dive. We've been talking a lot about, those different layers of security and how to protect your web apps. But now it's time to really get into like the code itself.
Yeah, we gotta, get into the attacker's mindset.
Yeah.
Figure out how they think if we want to build really secure applications.
So let's start with cross-site scripting, or XSS.
Oh yeah, XSS, that's a classic.
We've mentioned it a few times, but it's definitely worth digging into, like really understanding how it works and how to prevent it.
Yeah, so imagine this. An attacker injects some malicious JavaScript code into your website,
Okay.
and then that code, it gets executed in the browser
I know.
of like all your unsuspecting visitors.
Oh, so it's like setting a trap for your website visitors.
Exactly.
So what could attackers actually do with this kind of access?
Oh, all sorts of bad stuff. They could steal sensitive information,
Yeah.
like cookies, login credentials. They could deface your website, make it look all messed up.
Yeah.
They could even install malware
Wow.
on a visitor's machine.
That's terrifying. So how do they even get this code onto our websites in the first place? How do they like sneak it in?
Well, there are a few common ways. One is through forms. So let's say you have a comment form on your site.
Yeah.
An attacker, they could submit a comment that includes some JavaScript, right?
Right.
But it's hidden within like seemingly harmless text.
Oh, okay. So if you're not like cleaning up that input, that malicious code could get executed in other people's browsers.
Exactly, exactly. That's why input validation and sanitization, they are super important.
Right. So it's like having a security guard
Mm-hmm.
at the entrance to your application, just checking for anything suspicious.
Checking IDs, making sure nobody's bringing in anything
So
dangerous.
so it's not just about like checking what comes in, it's also about like cleaning it up
Yeah.
before you let it into your system.
You got it. You got to make sure it's safe before you let it in.
Yeah.
And it's not just forms that you got to worry about. Attackers can target vulnerabilities in how you handle URLs, API endpoints, even database queries.
Oh wow.
It's a whole world of potential attack vectors.
So this all sounds pretty complex.
Yeah.
I mean, how can we possibly defend against all of this? It seems like a never-ending battle.
Yeah, it can feel overwhelming, but there are definitely effective strategies that you can use. The first line of defense is, as we said, input validation.
Right, that security guard we were talking about.
Yeah, you got to check everything that comes in. But what about after the input's been validated?
Yeah.
What about when it's time to actually display that data to users?
Oh, yeah, good point.
That's where output encoding comes in.
Output encoding.
So basically, you're transforming any potentially dangerous characters in the data
Right.
so that they're displayed as text, not executable code.
Oh, okay. Okay, so like instead of displaying like the less than symbol, which could be like the start of an HTML tag, you'd encode it as like an LT. So it just shows up as plain text.
Exactly. You got it. You got it. And there are different ways to do it,
Yep.
depending on where it's going to be displayed, like HTML encoding, JavaScript encoding, URL encoding.
Oh, okay. So it's like having a secret code that only the browser understands.
Right.
So it can make sure that data is displayed safely.
I like that analogy. That's a good one. But even with all these measures in place, we can't get complacent, right?
Right.
New attack methods, they're always popping up.
So staying up to date is really, really important.
Definitely.
What else can we do to kind of stay ahead of the bad guys?
Security linters and scanners can be really helpful.
Okay.
They can help you find those potential vulnerabilities in your code.
Right.
And of course, thorough testing before you launch anything to production is essential.
Right.
And of course, OWASP, they're a great resource.
Yeah, those cheat sheets are they're like a security Bible for web developers.
They are. They really are.
Speaking of things that make you want to shout, let's revisit the dangers of dangerously set inner HTML in React.
Oh yeah, that's a good one.
I just can't get over that name.
Yeah, it's aptly named.
It really is.
It's a powerful tool.
Yeah.
But it can be a major security risk if you're not careful.
It's like giving someone a loaded gun and saying, just be careful with it, okay?
Exactly. And the worst part is it can be really tempting to use it,
Right.
As a quick fix when the normal ways of doing things in React feel too limiting.
Yeah.
You're like, I'll just use this, it'll be fine.
Yeah.
But trust me, finding a safer way to do it is almost always better in the long run.
So when is it actually okay to use this?
There are very few scenarios where it's truly necessary.
Right.
One might be if you're rendering HTML from a source you absolutely trust,
Okay.
like a markdown parser,
Yeah.
or a rich text editor. But even then, you need to be extremely careful,
Right.
and make sure the HTML is completely sanitized.
So no sneaky code hiding in there.
No sneaky code, exactly.
Okay.
Yep.
So what are some safer alternatives then?
Template literals or JSX expressions, those are good for putting values into your HTML.
Okay.
And if you need more control over how things are rendered, React's got this create element function, which can dynamically create those elements and their children for you.
Right.
And it's much safer.
So it's all about, choosing those safer options whenever possible.
Yeah,
Even if it means, writing a little bit more code.
exactly. A little bit of extra work is worth it for better security.
Absolutely. Okay, let's move on to another tricky security threat. We touched on a little bit earlier, but it's worth really diving into. And that's cross-site request forgery, or CSRF.
Oh yeah, CSRF, that's a good one.
So CSRF is all about tricking a user into performing an action on a website without their knowledge, without their consent.
Sneaky, really sneaky. So imagine an attacker sends you this malicious link.
Okay.
You click it, and boom. It triggers a request to your online banking site, let's say. and transfers money from your account to theirs,
Oh, wow.
all without you even realizing it.
It's like someone forging your signature on a check, but in the digital world.
Exactly. It really is. And it works because websites, they trust their logged in users.
Right, right.
So any request coming from your browser, they just assume it's legitimate.
So how do attackers actually carry out these attacks? What are some of the methods they use?
Well, one common way is by hiding those malicious requests inside seemingly harmless actions,
Okay.
like clicking a link or loading an image.
Right.
So you might click on a link, it looks totally normal,
Right.
but secretly it's sending a hidden request to
All
your
right.
bank, maybe changing your account settings without you ever noticing.
Oh, wow. So it's like that digital Trojan horse again.
It looks harmless on the outside, but it's got that malicious payload inside.
Right.
And attackers can use all sorts of tricks, forms, JavaScript, even social engineering tactics
Right.
to get people to submit those malicious requests.
So it sounds like, it's not just about those technical safeguards. It's also about educating users, making
Yeah.
sure they're aware of, suspicious links and emails and things like that.
Definitely. User education is super important. You got to teach people how to spot those phishing attempts and those suspicious links.
Right. All right, let's get back to the technical stuff. How do we protect our React applications from these CSRF attacks?
One really common and effective approach is to use CSRF tokens.
Okay. We talked about tokens earlier. Remind me how they work in this context.
So a CSRF token, it's a unique, unpredictable value
Okay.
that the server generates,
Right.
and it includes that token in every form or AJAX request.
Mm-hmm.
Then, when the user submits that form, the server checks, hey, is the token there,
Yeah.
and does it match what we're expecting? If it's missing or if it doesn't match, the request is blocked.
So it's like that secret password again that only the server and the real user know.
Yeah, exactly.
Yeah.
The attacker can't forge a valid request because they don't have that token.
Right. Okay, that makes sense. What about the same site cookie attribute we talked about before? How does that fit into all of this?
Same site is great for preventing a lot of those CSRF attacks, especially the ones that rely on how browsers automatically send cookies with requests.
Go. So it's like giving us more control over when those cookies are sent.
Exactly. By setting the same site attribute to strict or lax, you can make it much harder for attackers to hijack a user session.
But you did say it's not like a silver bullet.
Right. It's not perfect. It doesn't work perfectly in older browsers or with all types of cross-origin requests.
Yeah.
So it's best to use it in combination with other CSRF prevention techniques.
Okay. So again, it goes back to that defense in depth strategy.
Multiple layers of protection are always better.
Yeah. Okay. Speaking of layers, there's this particularly sneaky type of CSRF that I think we should talk about, and that's client-side CSRF.
Oh, yeah, that's a tricky one. So basically, attackers are exploiting vulnerabilities in your client-side JavaScript code to trick it into sending those malicious requests.
So instead of forging those requests directly, they're actually manipulating your own code to do it for them.
Yeah, it's really sneaky.
That's devious.
And what makes it even harder to stop is that those traditional CSRF prevention techniques, like those server-side tokens, they might not be enough.
So even though the code's been manipulated, those requests are still coming from the user's browser.
Exactly. So it looks totally legitimate to the server.
Wow. So how do we protect against this then?
The key is to make sure your client-side code is as secure as possible.
Okay, that makes sense. But what does that actually look like in practice?
It means things like using secure coding practices,
Yeah.
validating all user input really carefully, and avoiding things like dangerously set inner HTML.
Right. So it's all about being extra careful on the client side, treating it with the same level of security as we do the server side.
Exactly. You got to be aware of the potential for client-side CSRF, especially when you're using third-party libraries or connecting to external APIs.
So it's like building that security perimeter around your entire application, not just parts of it.
I like that.
Yeah.
It's about creating that security-conscious culture throughout your whole development process.
Yeah. All right, this part of our deep dive, it's really been a real eye-opener.
Yeah, me too.
We've explored the complexities of XSS, CSRF, and how important it is to secure both our client-side and our server-side code.
We've gone deep into those common attack vectors and learned some powerful techniques to protect our React applications.
Yeah, but there's still so much more to explore.
Oh yeah, we're just getting started.
And in part three, we're gonna broaden our perspective a bit. We're gonna look at some of those core pillars of secure web application architecture, things like authentication and authorization.
That's where it all starts,
Yeah.
building that solid foundation. We'll also talk about secure API design and how to stay up to date in this ever-changing world of security.
So many layers.
So many layers.
All right. Welcome back to our deep dive. We've covered a ton of ground, haven't we? Everything from JWTs and HTTP headers to, like, actually protecting React apps from those sneaky XSS and CSRF attacks.
Yeah, we've been in the weeds
Yeah.
looking at all the details,
Yeah.
but now it's time to like zoom out a bit, right?
Yeah.
Look at the bigger picture of web security.
Okay. So where do we start with that?
Well, we got to talk about the foundation
Yes.
of any secure application, right?
Yeah.
Authentication and authorization.
Right. Those two, they always seem to go together.
Yeah.
But they're different.
Yeah, they are. They're distinct but equally important.
Okay. So remind me, what's the difference again?
So authentication, that's all about verifying who a user is,
Right.
proving their identity.
Okay.
Authorization is about deciding what they're allowed to do
Right.
once they're in.
So it's like, imagine you're entering a building, right?
Yeah.
Authentication is like showing your ID at the security desk.
Mhm.
And then authorization is like, being given access to specific floors or
Yeah.
rooms based on your clearance level or something.
I like that analogy. That's a good one.
So in the web development world, how do we actually make sure we're implementing these things, authentication and authorization,
Yeah.
effectively? I mean, what are some of the options we have?
Oh, we've got tons of options these days. Everything from the classic username and password combo
Right.
to more modern approaches like two-factor authentication, biometric logins, single sign-on solutions.
And we got to mention OAuth 2.0 and OpenID Connect.
Oh yeah, those are game changers,
Yeah.
especially when you're dealing with third-party apps.
Yeah.
They've made it so much easier for users to give those apps access to their data without having to share their passwords.
Right. Right. It's like giving someone a temporary key to your house instead of handing over your master key.
Exactly. You're granting specific permissions
Right.
rather than giving them like unrestricted access.
Okay. Yeah, I like that.
Yeah.
But with all these different approaches, how do we know that we're actually implementing them securely?
There are some great resources out there. The OAuth 2.0 Security Best Current Practice
Mm-hmm.
and the OpenID Connect Core 1.0 documentation.
Okay.
Those are fantastic places to start.
So it sounds like, doing your research and staying up to date, it's really crucial.
Oh, absolutely.
All right. Let's shift gears a little bit. Let's talk about API security.
Oh, yeah, APIs. Those are everywhere these days.
Yeah. Connecting all these different systems, allowing them to share data.
It's amazing. But with that interconnectedness comes risk, right?
Yeah. APIs they're a prime target for
Yeah.
attackers. So we really need to be thinking about security from the very beginning.
On the design phase.
Yeah. So what are some of those like key considerations when you're designing a secure API? What do you have to think about?
Well, authentication and authorization are still crucial.
Yeah. Okay, so we still got to know who's accessing the API
Yep.
and what they're allowed to do.
Right, but it goes beyond that too. Input validation, output encoding, those are just as important for APIs as they are for any other part of your app.
So we still need those security checks
Yeah,
to
absolutely.
prevent, malicious data from getting in.
You got it. And what about those denial of service attacks? Where an attacker floods your API with requests, trying to overload it.
Oh yeah. Yeah.
Rate limiting,
Yeah.
that's essential for preventing that.
Rate limiting. Okay. So it's like having a bouncer at the door of your API, controlling the flow of traffic.
Making sure nobody gets out of hand.
Yeah. I'm starting to see how API security is like a whole world unto itself.
It is. It really is. And we haven't even talked about things like using HTTPS to encrypt the communication,
Oh yeah.
implementing proper error handling, setting up comprehensive logging.
So many things to consider.
So many layers, so many things to think about.
It sounds like, building a secure API really requires that holistic approach.
It does.
You got to think about all those different angles.
You got to think like an attacker, try to figure out all the ways they could potentially get in,
Yeah.
and then close those gaps.
All right. Well, I feel like we've covered an incredible amount in this deep dive.
We have.
We started with those building blocks of secure coding. We looked at how to protect those specific types of applications, and now we're looking at like how to design those secure systems
Yeah.
from the ground up.
We've talked about securing JWTs, preventing XSS and CSRF attacks. We've delved into authentication, authorization, API security.
But I think the biggest takeaway for me
Yeah.
is that web security, it's not like a one-time thing.
No, it's definitely not a set it and forget it kind of thing.
It's a journey.
It's a process.
It's a process, yeah.
A continuous process of learning, adapting, and improving those defenses. Because, the threat landscape, it's always changing.
So where do we go from here?
Oh.
How do we continue on this journey? What are some things people can do?
Well, luckily, there are tons of resources available. Organizations like OWASP, SANS Institute, NIST, they're all fantastic sources of information.
Yeah, and they've got all sorts of stuff, right?
Yep.
Like cheat sheets, best practice guides, vulnerability databases.
And don't forget about the community.
Oh, yeah.
Connecting with other security professionals.
Yeah.
Through, on the forums, groups, that can be so valuable.
Yeah, you can share knowledge, learn from each other's experiences.
Absolutely. And of course, continuous learning is key. Books, online courses, conferences.
And podcasts like this one?
Exactly. Podcasts like this one, they can all help you stay sharp and keep those security skills evolving.
It's like any other skill, right? You have to practice, you have to keep learning. But the great thing is, learning about security can actually be kind of fun.
It is. It really is. It's like solving puzzles.
Yeah.
Becoming a digital detective, uncovering vulnerabilities, finding creative ways to protect your apps.
It's about embracing that security mindset.
Totally.
Yeah.
Staying curious, never stopping asking questions.
And with that, I think we've reached the end of our security deep dive.
We made it.
We made it. We covered so much, but hopefully you're feeling a little bit more empowered now.
Yeah.
To tackle those security challenges in your own projects. Remember, security, it's not an afterthought.
No, it's not.
It's a crucial part of building those really robust, resilient, trustworthy applications.
Absolutely. So stay curious, stay vigilant, and keep learning.
And until next time, stay secure.